Okay, I'll go ahead and get started with sort of our front matter for the biomass webinar series. Thank you all so much for being here. My name is Emily Heaton, and I'm a professor in the Crop Sciences Department at the University of Illinois and one of the organizers of the biomass webinar series. We also have several sponsors associated with the biomass webinar series. Many of them are at the University of Illinois, but not all. So the purpose of the biomass webinar series is to explore how perennial biomass crops and emerging biomass supply chains can support resilient agriculture that includes sustainable manufacturing and regional economic development. So everything from energy to products to chemicals, those are all the things that are under the umbrella for biomass products that are important for domestic manufacturing and strong economic development, where hopefully we control our own markets and our own supply chains here in the Midwest and the rest of the country. So this summer, we are going to be featuring talks that are related to perennial crops at large, but there will be a focus on some of them on miscanthus or switchgrass industries, things that are related to climate smart management and more. So the webinar is hosted primarily by the University of Illinois and Iowa State University. Andy Van is online, and he, I think, will be leading the webinar next week while I'm on the road driving back from Iowa. We are sponsored in part by the Department of Energy's Center for Advanced Bioenergy and Bioproducts Innovation, by the USDA's Diverse Corn Belt Project, and by iRegen, which is a group of philanthropies coming together to support health and wealth outcomes in the Midwest. So you can register for the webinar series using this QR code here or the link. If you're here, you probably already figured out how to do this, but if you have friends who want to join in the future, they should use this link to get on the registration list, and that will help us not only make sure they get the link, but also have the chance to contribute their thoughts about the series. So today we have Dallas Glazik. I am delighted to kick off this summer's webinar with Dallas, and I think this is particularly interesting because, as Dallas reminds me every time we chat, I don't like miscanthus, right, Emily? So this is part of the point here for us to understand how multiple crops and multiple conservation strategies fit together in our agricultural landscapes to develop health and wealth that works for all of us. And then next week, we will hear from a tag team presentation with Allison Bishop at Hertz Farm Management and Steve Schomburg, one of the OGs of miscanthus production in the United States. So with that, I will turn it over. Oh, I'm sorry, quick advertisement for our first International Miscanthus Summit. Hard to believe we haven't done this in the US yet, but the University of Illinois is hosting a 4-day summit in October that will be 2 days of science. You can register for that separately if you want, plus 2 days of trade show and field demonstrations. We'll do miscanthus planting, miscanthus harvest here at our energy farm, and we'll also feature the oldest measured plots of miscanthus in North America, as well as the breeding program. So I hope you can join us for that. So with that, I'll turn it over to Dallas, and you should be able to share directly from your screen, Dallas.
Thank you, Emily.
Oh, I did not give your titles because you have several.
That's all right. I got a spot where I'll jump into that. So
Perfect.
I'm just gonna do this. All right. Emily, the participants they did and the chat stuff disappears on mine once I share. So if anything pops up, feel free to speak up and let me know.
Okay.
But can you see the slide all right?
Nope, right now we're seeing the other screen. So I think you need to.
Yeah, try sharing just the PowerPoint itself and not your whole window or your whole browser.
Yep. There, I found it. All right,
There we
how
go.
about now?
Looks good to me.
All righty. Yep. And so, yeah, as Emily was saying, I do wear multiple hats, farmer, a distiller. Fun little fact: if you want to talk about Kernza and how it processes, our distillery in Paxton actually is the U.S.'s largest processor of Kernza, turn it into distilled spirits. But today I'm going to be talking about my work with Pheasants Forever. So I'm the ag and conservation specialist, where I'll actually help farmers really turn red acres green. And that's not a reference to their tractor preference. That's actually a reference of finding unprofitable acres on the field and different conservation and other alternatives for that grower to then make a profit. So my particular talk is going to be about isolating out these locations that perennial-based crops, biofuel-based crops, conservation efforts we'll be going through. Most commonly that I work in is habitat planting, so that it goes into a perennial system such as CRP, with which is Conservation Reserve Program, if you weren't familiar, out of the USDA program. So those are going to be the main aspects that my examples are, but it can definitely be relayed well into biofuels and just diversification of the landscape. A little bit more about me. So I'm a University of Illinois graduated in 16 with a concentration in restoration ecology. And then as well, grew up on a family farm. So I'm a fifth generation farmer where we actually implement quite a bit of diverse crops and as well as livestock, and really starting to put in prairie and other conservation practices. I'll have some slides actually highlighting my particular farm that we'll dive in. And I've been with Pheasants Forever for over 8 years now, so it's fun being able to work with other producers and on our own farm, implementing some practices that I can then tell farmers that, yeah, these do work because I do them myself. So what I found out is that farming is really a breakdown of two different pieces. So you have both the business aspect and ecosystem management, and if you focus too much on one, the other one will start struggling. And we start seeing this whenever you look at the U.S. as a whole. So big push for yield, but more yield does not equal more money for that farmer. And you can see the graph there. So we are getting extremely well at producing bushels. And looking at our landscape, 15% of all U.S. land is actually dedicated to just 4 different plants. And so when you start cutting out a lot of that biodiversity, you're going to decrease a lot of your natural services. And as well, we see the biodiversity starts declining. So here we have matching maps, but while that yield goes up, we actually have other ones. So we have statewide pheasant trends and monarchs pictured here that are declining, with some slight increases up in that 2016 range, which, if you guys are familiar, that's when the pollinator program came out of CRP, and we started seeing some more large-scale implementations of prairie back in the landscape. And one reason why that is happening, so here, if we look, this is a habitat chart that showcases the preferred succession type, community type, that a lot of species within our area prefer. So we're talking here in Illinois, we're going to be looking a lot from that end of bare field through grassland, grass shrub, and that's going to bring in the most amount of wildlife within there. And so if you go into old time oak hickory forest, you're going to be losing some, but we're in that grassland area. So we're going to be looking at that 1 to 3 year community type, which matches well with an agricultural based system. Just fun one here. So like I said, as that biodiversity goes down, you're removing those species out. You're replacing these natural services with added inputs. And so here we're looking at net cash income for U.S. farms. And so you can see the receipts have greatly increased, but as well have the production expenses. And when you start to equate that for inflation, farmers in 1910 actually profited more per acre than they do today. So this particular graph ends at 2018, but it still trends that direction. And we can really see that with some of the work that ag economist out of University of Illinois, Dr. Gary Schnitke, puts together. So these are his 2026 projections, and this is focused in on central Illinois. So we're looking at the, Champaign, Decatur kind of area. So what is considered prime farmland. And corn profits are still supposed to be expected to be a negative $73 per acre and a negative $50 per acre for soybeans. And that does not account for some things that's ad hoc federal payments and stuff like that. But I always like saying, if you're operating at a negative without government subsidies, you're still operating an unprofitable business. And we see that going through. Here's another graph. So you can see the area that this research was done. And there is going back to 2023, a negative in regards for farmers working, unless there is subsidies put in there. And so we're at the point now we're really starting to see, 3-4 years of operating in a loss. I even know some farmer friends myself that have given up acreage just because they cannot afford to continue to lose or pay the cash rents that are also increasing. And so when it comes to conservation practices, so I made up this little graph I really like because we have people that would have put in their ground 100% in the habitat, of course, on their side, and you would have people that are never going to put in any habitat, and they're going to continue to farm fence row to fence row. And most people are going to be living in the middle, and they're really going to be concerned about that bottom line and being able to carry over. I really like this quote from A.J. Blair back in 2016. He says, "Production agriculture is a business. You have to make enough money to farm again next year. The hard truth is that farmers don't care about soil health, wildlife, or water quality if they can't afford to farm again the next season." So that's one that I really take because it is. You have to think about that business. You have to think about the ecosystem services, and they got to be paired together. And so my work is we show how conservation is going to pay. So looking at this here, this is a common one we see here in Illinois. We're going to have up against a tree line, and these are ears taken out of that tree line. And it's really hard to see exactly where you lost money. You can see a decrease in bushels, but if you don't compare that to your expenses, you're not knowing exactly where you started losing. Same as this one. This one's probably more familiar for people here this summer, but we know that we're losing where there is not a crop growing and where it's died, but it's harder to see exactly how far in that impact will actually go. But it's getting increasingly more common to have precision ag applications and easier to identify. The technology that farmers are now getting and putting on equipment is really extensive. Even at that bottom right corner, you can see that farmer is actually watching Netflix while he's in the tractor. And if precision data on a farm can input this into with a tillage unit, surely we can find a way to put some conservation on the ground. And so now we're going to be going over some examples. So this one is in Piatt County, Illinois. So here we have yield maps, and a lot of farmers will collect these and they look at them. They know that the red means it's a lower yielding, green means it's higher yielding, and you got your color variance in between. However, what we do is we'll take it, again, those expenses and overlay them together so we create a profit loss map. So now red means you lost money, yellow means you broke even, and green means you were profiting. And whenever we look at multiple years, we can then stack those different years that are continuously losing, and we can start a design plan. So here we can see this field. One spot that always comes up, I have yet to find a profitable end row. In any of my work that comes through there, you have compaction issues, you have the same amount of inputs and applications on it, but they're just not performing well. So it's always a perfect idea to look at a field border or another solution along that. Now with this, you do have to still use it as your end row in agronomic based purposes. Otherwise, you do just move that problem further into your field. Another ones, wet spots are commonly known and really easy to spot. And with the auto steer guidance, so this one, the shape, while it is unique looking, actually lines up exactly with that farmer's planter and equipment. And so that's why those lines are there. So it cuts back on his point rows, any double applications, and he's able to map it back and forth just fine. One question I get asked a lot is about opportunity costs. So this is compared to a CRP payment. If that farmer, so that we have the blue dots are now representing uh, potential areas that are yielding higher than what a CRP payment would. But out of the 25 acres, that only accounted for 5 acres of it that would have been a penny or more above the CRP payment. So that's kind of a little bit of an example of kind of what we're doing, but going to go into some more hard examples. So this is in northern Ford County, this particular project, and outside the town of in between Piper City and Chatsworth, if you're familiar. And so this farmer came into the office and he was initially actually interested in adding more tile because he was having an eroding stream bank and he had wet and hard to farm locations as well as some eroding hillside or hill slopes. And so he was wanting to put in tile and do a little more water management. Well, he bumped into me instead. And so we started talking about his data. So here is an aggregated 4-year average yield map. So this is a representation of 4 years of yield history, all put into one georeference point. And so we have this map here and compare it to his expenses. Now, one that is common for a biggest loss is going to be a cash rent scenario. But this farm was actually working on a 50-50 operation. And so we were able to dive in a little bit deeper. So he would show a higher profitability than in a standard cash rent. So now we have that profit loss map. So again, this is a 4-year historical profit loss map. So we're showcasing where he's losing money, where he's making money, and where he is breaking even. And those low yielding spots and the spots he was having a hard time and not wanting to farm anyways, they are showing up as this as low profit. So he was actually in a particular location that had U.S. Fish and Wildlife involvement and an interest in wetlands. And so we decided to look at the plan and the wetland potential. So this would be the number of acres on this farm that would get at least 18 inches of water if a small berm were to be put up. And so we kind of went with that plan. Of course, he didn't want to do all of that. He wanted to still be able to farm some on the farm. So we looked at and we took out 27 acres and put that into a CRP wetland program and a mix of pollinators. So we can see we targeted the areas that was eroding slope. We targeted the areas that were wet and hard to farm. And the wetland basins actually feed into each other. So the water level makes it really easy to control. So you can constantly drain one into the other one so you're not losing your habitat value, but you're able to maintain one further upstream or downstream. But what we see is by isolating those acres out, he's actually going to save $5,940 per year. And that would be if he just picked the planter up. If he did not plant corn and soybeans within those areas, that is what he's going to be saving. Now, since he went into a government payment, he's going to be getting paid on it, or a government program, he's going to be paid $5,119 per year by putting this into this wetland system. And so that's a difference of $11,059 per year profit increase on this farm. And so since he was interested in tile, I always throw this in here. He's 3 to 5 years to break even on tile in our area. And so he's going to be $33,000 to $55,000 ahead than if he were to put in tile on these locations. And so it's real easy to find these and look at some different alternatives other than just more corn and soybeans. As well, you get a lot of additional results. So we have a savings of 81 tons of soil each year that was eroding to that green dot right there, and reduced total input costs by 35.22%, all while building wildlife habitat and as well as squaring up his field. And so it matches his equipment, so he's able to get in and out of the field quicker. Going to be going over that site as well. So this is it during construction. You can see the berms that were actually built with the intention and width and slope design, so he can drive his equipment across them to go from one side of the farm to the other. So he won't have to go all the way around back on the road just to cut through the middle there. So he can drive across these berms, and they won't be deteriorated because of that. Here's just a idea of the perennial mix that was seeded into there and the rates with it. One thing I do want to point out, since it was a wetland, that if you notice, there was no aquatic vegetation. So these cattails were just sitting within that seed bank with a farm that would have been well over 80 years of intensive ag use. And so these aquatic vegetation was sitting there. You just add a little bit of water and they are going to grow. And then waterfowl was able to find it. So this is the spring right back after. And then the important thing, since he was a 50-50 and operating more in a family-based structure, he was able to pass it down to the next generation. He was wanting to get ready to retire with his son wanting to come into the farm. And whenever you're looking at these opportunities, the difference between $33,000 and $55,000 was saved up over 3 to 5 years. That is a way for a younger farmer to buy back into the farming business. And so the equipment nowadays is a lot more expensive. It's not buying 6 and 8 row planters. It's buying 12 and 16 row planters. And there's a cost that's associated with that. And so by looking at the efficiency of the farm and making the most profit on there, that's whenever you can pass it off to that next generation. But I'm going to dive into a little bit more of how conservation will actually pay more with it. So some of the benefits and the inputs that are being provided by our natural services. So if you look at a standard cornfield, Dr. Jonathan Lundgren did this. So he is out of South Dakota, also a U of I graduate. And he was looking at a standard cornfield of how many insects were there. So we found 107 insect species on that acre, and diving into what they were, found that only 7% of these insects were possible pests. And so that leaves 93% as beneficial insects or just non-binary. They're not harming anything, but he equated those to beneficial insects. And you're looking at 137,000 to 161,000 beneficial insects per acre in a standard cornfield without habitat around there. And as well, when you look into birds, so birds and adding edge of field and especially with a little bit of trees will actually increase the amount of birds, and you can see a 33% reduction in your pest insects on that. And I would like to point out again, we just looked at the fact that only 7% in a standard cornfield acre are possible pests, and birds are not that picky when they come to eating their insects. And one barn swallow is going to eat 60 insects per hour, which equates to about 850 insects per day. And they're flying around. That's how you get that reduction of your pest insects. One thing to really keep in mind when you are isolating out these particular acres is to keep that design, the habitat based on the field size and equipment size. And if you're not familiar with standard equipment sizes, one thing that I always put in there, 120-foot field interval. So if you were to keep it with 120-foot passes on your field side, that's going to line up with most equipment. So that'll be anywhere from a 4-row, a 6-row, 8-row planter, all the way up to a 24-row planter will work on that 120-foot interval. It's once you get into the 36-row planters that you're going to be stretching that 120-foot a little bit tight. And so that's whenever you base it off the equipment, it really squares up. So here's a farmer also in more central Ford County, and we can see he was operating at a loss on this 88-acre field. Didn't realize it because he was farming across the way as well. So he just had the same truck, went to the same elevator, and so it was all kind of be blended in, and didn't isolate down this particular farm and the acre by acre. And so we isolated out 32.6 acres that was going into a CRP, which brought him up to a profit. But if you notice as well with this field, he's squared up and designed so he can actually run east and west and north and south, and it'll line up his equipment, and he'll end up back near the point of starting so he can then move on to the next field. He was actually saving an hour of operating on this farm. So that means that he can get in, get out. That's an hour. You can get to the next field. If you're paying labor, that's an hour less. That's an hour less of fuel. So it really starts adding up. Just a little bit. This is a picture of it a couple years later. This is a monarch migration that came through. And just by adding just a few trees within these field buffers will actually increase the bird species from 5 species on average up to 13. And if you're, again, thinking that a healthy bird population will reduce pest insects by 33%, by having more of those birds there, you're going to get more of those benefits. This farmer also, he was saving an average of 39.12 tons of soil each year and reduced his overall input expense by 46.3%. And a lot of that was due to taking out the overlap in point rows and in the time savings. And one that is going to be really noticeable here. So just a 10% reduction in a standard field size and placed into something with more biodiversity can lead to a 5 to 30% yield increase in soybeans. And this is something that I've done on my farm as well. And if you interseed buckwheat, Ohio State, they were the ones that did this. They actually saw a 40% yield increase with the native habitat and buckwheat interseeded into the soybeans. And one that if you have pollinating flowers along with clover, you can see a 16% higher bee populations and increase seed and yield within that system. One that is brought up, so like I said, I've been doing this for 8 years now, and what I've noticed is actually increasing a farmer's APH. So now we're going to be tying it into a little bit more of your crop insurance based systems. And so we can see how isolating out these low yielding areas, placing them into something that is not corn and soybeans, will actually increase the guarantee and payouts of crop insurance. And if you're not familiar with APH, it is actual production history, which is an average of 10 years of the yield produced on that farm. So this farm here is in more central Champaign County. So he is in what is a lot of people consider very, very prime farmland. Have NDVI imaged here because the yield maps at this scale, they weren't wanting to show too well, but you can use NDVI if you don't have yield to actually estimate out some of these low productive areas, because it is measuring plant stress, and stress of the plant and yield do over correlate well. But here we can see, just zooming down on this 83.1 acre, there was just this one little corner he was most interested in, and we isolated that out. So you can see just a small reduction of 7.85 acres increased his average yield on the farm and dramatically increased his profit. So he was spending a lot of money just on this tiny little piece. So he's able to increase even more. And that's something he didn't even notice because it's just 7 acres. It just blends in. You think it's, overall you're still fine. But if you start isolating out these locations, you can have dramatic increases. He was actually interested as well. He was a cover cropper. And so on this farm, like I said, I've never found a profitable end row. And so he was interested in starting to grow his own cover crop seed. So this is cereal rye. So he would put out his cereal rye and no-till in his soybeans. And he just would not plant soybeans or use any of his other chemicals and inputs on the end rows. So he would still turn on them and then just start planting right back up. And then he would come through and harvest this cereal rye. And he was able to make enough cereal rye off this 9 acres of end rows to actually cover 240 acres of seeding rate for his cover crops the following years. And so you can see a slight decrease in that profit line on it. That was isolated just of this farm. But if you accumulate the operation, his profitability went up. And so now we're looking at the CRP plus the cereal rye there. And if you notice, because you're isolating out those underachieving acres, that average yield is increasing. And what we're doing is, as we are removing those underachievers, we are shifting this bell curve on the APH. So we are going to increase that APH and focus our efforts more on these top performers. And if you're not familiar with how crop insurance gets calculated out, you have actual production history times your spring price times the coverage level, and that's going to equal your guarantee. Now, a farmer, they have a say in changing 2 out of those 3 pieces of the equation. So they can change their coverage level and either take on more risk themselves or pay a higher premium for more coverage level, or they can adjust their APH, and that's going to be increasing their yields, which can be kind of hard if you're just putting more and more inputs on it. That doesn't mean you're making more profit. And so by removing those more marginal acres that are underachievers, here in this example, so if we had the average APH of 231.59 bushels times the spring price, which gets set, he's going to end up with a guarantee of 903.55. But by isolating out those particular areas, we can actually increase that. So he's going to have about a $30 more guarantee per acre whenever it comes to a crop insurance claim. And the cool thing about this as well, you're removing the riskier acres. So you actually end up claiming less, but when you do, you make more. So it makes your farm more resilient to those risks and environmental conditions, and you get paid more whenever you do need to make a claim. One that I'm adding in here, because I know it's going to be talked up well going into the biofuel, is actually looking at the carbon intensity score. So being able to calculate out. So he was interested in receiving some of this information because he is looking at selling into the ethanol market. And so a carbon intensity of farmer is going to have to be about 26 on a carbon intensity. And so that is grams of greenhouse gas per megajoule produced. And so if we're looking at the GREET model for this particular example, and as well, they keep changing some of the rulings on it where they had more CRP and cover plant or allowed for carbon reduction. And if you are looking at that, 1 acre of tall grass prairie here in Illinois is going to sequester about 5 tons of carbon per acre. And so that can really start adding up. And I've seen it within the GREET model of it's allowed or if it's not allowed for the use of 45Z. So I'm hoping that they straighten that up because we can really see that a farmer can really have a great impact there. So if we're looking at just this particular example, if we were going to be taking out that 7.85, that would drop him from the 29.1 down to a 23. And again, a farmer will have to be at a 26 or lower in order to move the needle of the carbon intensity at the ethanol plant on their side of the equation. And so just looking at the farmer side, by isolating out that, we can drop down to a 23. And by the use of covers and not planting the soybeans within there, he actually drops down to a 20. So if you are looking for a farm-based carbon intensity, by isolating out these underachieving acres and looking at a alternative system is a quick and easy way to make that happen. And one way that we're going to be doing it, and it's growing here in the state of Illinois. Illinois actually leads the nation in the adoption of prairie strips on the farm. And we're going to be going over this example here on the border of Ford and Champaign County. So Rick and Isa, they have a 50-acre piece of land. They wanted to install prairie strips. They're installing prairie strips on more with a total of 2,200 acres that they operate. And so this is the plan here. So these are 30-foot wide strips that were planted every 120 foot, and why he did 120 foot. And so now he can apply foliars and other inputs as needed on this farm. So he can actually drive down those prairie strips because he did non-program. And so these were done on his own. And so he can drive down those strips. It's going to increase the amount of pollination within those fields. And if you start thinking about pest control and stuff, because he was actually able to cut out all his insecticides on this farm. And I started doing more research with the University of Illinois. He had some entomologists come out, and we started noticing that insects really like to stay within 200 feet of a perennial habitat source. And the insects that we're looking at are going to be things like field crickets and beetles, that they will actually go in and destroy weed seeds. One field cricket can actually disable 4,000 lamb's quarter and ragweed seeds in a single summer. And then as well, if you're looking at your parasitic wasps, that will actually, they like to go in within like 100 foot of a nectar source, or in this case, a prairie, because the adults are They are nectar eaters, so while their larvae are going to be parasites on other insects, the adults are feeding on flowers, and in particular things like frost aster, goldenrod, and other short tube flowers. And so by having these strips integrated in the field, you're going to bring those insects further into your operation and increase the amount of benefits you're getting. So going over just kind of how this was done here, you can see the first year that they were planted. Since he did it on his own, he did not have that diverse of a mix, but we noticed that really diversity will fill in a lot of your niches and help on your weed control and bring in more species. But if you just by putting something out there and getting it started, since then he's gone through and enhanced these strips by adding more species to get more benefit. But they can be really affordable to get started and get going. But here they are the following year. So this was right after an 8-inch rain event, or a 6-inch rain event, my apologies, that happened here in within this area back in 2020. He actually had a 420-acre watershed that was coming through this north part of the 50-acre field. And the neighbor had to take a backhoe to fill in his goalie, while Rick here actually had an 8-inch buildup of soil at each one of these prairie strips. So prairie strips are extremely effective at soil control and extremely cheaper and easier to establish than terraces. And so they was actually built up a little bit too much that he was wanting. So we did go through and he dissed and was able to spread that out. So I always like to make the joke, Rick is the only farmer here in Ford County that is increasing soil without the use or without having to buy it. But as you can see going through, he was trying out different management. He was looking at burning the strips, letting some just kind of more go and see what happens, and then as well as grazing some. And he is diversifying his income by doing grazed pork, pasture pork. And so these pigs are, I was kind of leery at first whenever he was talking more about it, but the pigs are actually extremely good for prairie management. I don't know why, but they target a lot of the weed species such as lamb's quarter, dandelion, rooting up thistles whenever they're in their basal stage, and cottonwood trees. They will just dig up a cottonwood tree and eat the root. And so they're really good at targeting the woody vegetation encroachment onto a prairie, and as well as that cool season vegetation that's going to be combating the warm season natives. Just here's a picture of them. This black-eyed Susan, the pigs ate all the way around it and left it. And so if you're wanting to work on some management and have the ability to graze in some pigs and rotate them through, I would highly recommend it, because I do not know the science of why they don't like eating on the natives, but they'll leave them alone. And so it's really, really good for management systems. Going to jump to my farm here. So here you can see a field of soybeans that has the buckwheat planted into it. And what we've seen on our operation is actually we've seen haven't noticed a big yield increase within our soybeans just yet, but we have seen a increase in our test weights. And so by increasing those test weights, in the reason I've been whenever asking some professors that so the buckwheat is going to bloom about 2 weeks before the soybeans do. So that brings insects into your field. And while soybeans are capable of self-reproduction, when you have sexual reproduction, you get a higher, more efficient test weight. So it's going to increase, you get better pollination whenever you do have the insects around. And that is what's increasing the test weight. So again, going over just some highlights of the insects and kind of why we are bringing in these insects directly onto the farm. Isolated out and on the home farm of 400 acres, actually removed 34 acres that was found to be unprofitable and put that into prairie. And so we're bringing in a lot more of this diversity on our own, and as well as working with management of burning and grazing whenever we can and allow it. Here is the home operation. This is just outside the town of Paxton, so about 35 minutes north of the University of Illinois. And you can see our farm is split up into a big diverse rotation. So here we have the different colored fields with prairie strips installed in between. and with rotational grazing through. And so this one operates on a 7-year crop rotation. So it means one particular field is not going to have the same crop on it for another 7 years, which is great for any pest management, weed management, insects, and building up your soil organic matter and biology. And we put in a lot, so we'll actually go through and throw in a lot of diversity, always trying to keep the soil covered. And it's kind of funny what I've done my Russell numbers. So if you're not familiar with Russell, that measures out the amount of soil erosion. And we still do, since we're an organic operation, we still implement summer and fall moldboard plowing. And with the diverse rotation and the use of cover crops, so after we plow, we'll immediately put on a mix of either peas, oats, turnips, radishes, or any of those kind of in particular. We try to hit a 4 of a legume and a brassica and a grass. So try to hit the big 4 whenever we are putting in our covers. And so while we are still moldboard plowing, our T factor, so what calculates out as our soil erodibility, is in the reduced tilled application there. So while we're doing something that is deemed really extensive, by spreading out over that 7 years, it is really not that impactful on our operation. As well, I always try working with natives as much as I can, starting to integrate partridge pea and Illinois bundleflower into the rotation. So these are warm season legumes that can actually fix as much nitrogen as clover and alfalfa, but they come on as warm season. So you can then run an experimental patch of actually planting corn directly into this cover crop mix and then using a prescribed fire after the corn is spiking up. And that's going to set back and terminate right then out of the gate. And the corn can then grow, but the Illinois bundleflower and partridge pea, being warm season, will actually grow up underneath that corn. So it will start germinating. Soil temperature is about 70 degrees. And so you're able to keep that continuous cover because they can handle the fire. And so you can have it growing up underneath. And we'll see how this experiment kind of all goes. Hopefully I can talk more about the successes or failures of that as it goes through. Just kind of mentioning the fact that diversity is key, I've noticed, whenever you're doing this, because you want to try to get as many of those natural inputs in as possible. Going over, I get asked a lot about the buckwheat within soybeans. And so here it is, planted directly into the planter box. Our population rate is 200,000 population on soybeans, and integrated mixed into it is a total of a quarter of a pound of buckwheat per acre. So it's an extremely inexpensive way to increase your test weights, increase your yield, bring in those insects. And so here you can see at first cultivation pass how the buckwheat is barely even noticeable within there. They are growing together. Coming in at the second row cultivation pass, you can see that buckwheat is starting to bloom. I apologize, I need to update this photo because it is blurry there. But yeah, the buckwheat is blooming, starts to bloom about 2 weeks before the soybeans do, and it'll continue to bloom through while the soybeans are blooming. And that's when this picture here, the soybeans are blooming underneath, the buckwheat's blooming on top. And whenever I was taking this picture, I was just being buzzed around by a bunch of insects. So it's definitely bringing them out. And one thing I'll as well notice, you can look at the color of the flower, and that's going to be things within your forbs. They're going to be mineralizing out different nutrients. And I believe it's phosphorus is white flowers. I'll have to double check on that one. But yeah, so you can, I know yellow flowers will actually mineralize and help make calcium more available. And so you can utilize that based off your fertility needs. And the buckwheat does help choke out small foxtails and other weeds that we're going to be seeing within that system. But by doing all these, we're actually part of a ornithology study out of University of Illinois. And so they're coming through and they are counting out the different bird species within our farming operation. So this is on the farm. This is not looking at any of the prairie, anything like that. And what we see is that the diverse home farm, the longer they've been within this diverse cropping system and having all that rotation, the more abundance we start seeing. But we'll notice that down at the bottom there, those were actually within the system for just 3 years. And the top was, of course, has been going back to 2002. So they start finding these spots pretty quick, and they'll come in. But the longer you do it, the better off you're going to be. And the birds can really eat. So here is a Smith's longspur sparrow, which is actually a rarer sparrow here in the states of Illinois. It migrates through, and they are hungry. And so whenever they're migrating through, this is in a just planted cornfield. You can see a corn earworm larva that was happened to be caught on camera, and these birds are picking for them and snatching them up. But yeah, so when you work with nature, it definitely gets easier. And whenever you isolate it out, those particular acres, you add that diversity, you're going to be reducing your overall expenses and increasing the profitability of your farm. Just kind of a wrap up here. We're looking at standard farming practices can have poor ROI. Just the focus of yield is not going to make you more profitable. Modern technology can isolate out those low areas. You can then replace those input costs with natural services. And as well, the perennial habitat can increase the yield overall. And if you build it, they will show up. And with that, I'm going to hit escape and stop sharing and answer any questions.
Thank you so much, Dallas. What questions do we? I know some of you have to go. We're a little over time, but if you have questions for Dallas and you want to stick around, please either put them in the chat or go ahead and unmute and ask him directly. So Andy's going to kick things off. Go ahead, Andy.
Thank you. Sounds on? Yes, it is. Great talk, Dallas. Thank you for that. Could you tell us a little bit about the transition period when you, that insurance example you gave with taking the triangle out of production? Is there a bit of a transition period before you have the actual production history updated, or do you just redo the analysis based on the new acres and you're immediately locked into a kind of a deal?
Yeah, so APH, it is an aggregation of 10 years. And what I've been seeing is you start seeing that impact come about year 4. So that's going to give you enough within a standard crop rotation that you can see your APH naturally increase. But we are looking at it. There are ways you can work with FSA to section that item off. And you can get a more immediate result by doing so, by splitting that field line. And as well, actually, Pheasants Forever are going to be rolling out this summer. It's going to be an initiative to where we are incentivizing farmers to run these plans and help cover the cost of that APH increase as that time goes on. So there is ways to get that benefit faster, but you are going to be looking at that average of 10-year to see the full impact.
Great, thank you.
Yep.
Other questions for Dallas? I certainly have them if other people don't jump in. So Dallas, a couple questions for you. How many people like you are there? How easy is it to find a Dallas Glazik to help you think about increasing the value of your fields?
Yeah, so in regards to Pheasants Forever, we have 18 across the nation, precision ag and conservation specialists. We actually just conducted interviews for another one here in Illinois because I have been the only one covering the entire state, and it is quite popular. And I've noticed it's hard to be effective whenever I'm having to drive to Joe Daviess County. And so whenever you got a 4-hour one way, so we're splitting the state and hopefully increasing that effectiveness. But in a lot of it, I've noticed and built out models. And so while having that combine data directly from the field is going to be the most accurate, by utilizing NDVI and other spatial technology out there, you can get down really accurate. So I've gotten down to half a bushel an acre of accuracy on yield estimates. And so if a farmer is new to data collection, you can utilize those yield estimate maps and that NDVI to actually increase the accuracy of that historical time frame to isolate those out. So if anyone wants to kind of look at their farm overall, you can go. There's a couple websites out there that utilize NDVI for free. Datafarming.com for one, and you can draw in your field boundary and start seeing your own stress maps. They're updated every 3 days, and so you can see exactly whenever you do tillage.
Thank you. And then one more question. There's been a lot of changes to conservation program funding or potential changes. Um, what's the space for new CRP adopters right now?
Yeah, so they did. I believe they just increased the amount of CRP, the cap limit on it to 2.2 million. I think is what they increased just now. But the big thing that I like stressing, and why I pointed out on one of the examples, the one with the wetlands, he was going to be just shy of $6,000 a head if he did no. So that was without CRP. That is just management change on that land and saved inputs. So that's still $6,000 more on that 160-acre operation without government programs. And so, yes, the government programs, they are the cherry on top that will pay you to put in these adoptions. But there's state programs, there's fish and wildlife programs, nature conservancy programs that can help cover the cost of installation, and you're still going to get that benefit.
Thank you. So I have one more question that kind of ties this to other topics we'll hear. So next week, when we hear about Steve Schomburg's farm, Steve is one of the adopters of the strategy that Dallas has just described today, and then taking it to the next level by adding other crops that have direct market value, like miscanthus.
Yep.
One of the questions that I get a lot is why not just use prairie directly for biomass and energy and bioproducts? I know I have some reasons why, but how do you feel about that, Dallas?
Yeah, so I mean, prairie itself is not as it's not going to be as efficient of a biocrop such as miscanthus. I know they've bred switchgrasses in order to do that as well, but prairie itself was designed for the biodiversity and continuation of encycling its own nutrients, and so bioenergy can be nutrient draining out of that particular spot. And so prairie itself, I don't think makes good bioenergy, but as well as finding these locations, it's the same process. I mean, you're still finding that area that's not profitable within a corn, soybean, or wheat crop rotation. And now you got to sit there and think about, let's do something different. I mean, some of the farmers, they could have seeded that down in clover and, grazed it or baled it and still saw those same effects and benefits. Just with the promotion of the prairie on there, you're going to be getting more biodiversity and more of those beneficial insects and wildlife that can come in because you're building them their home. So if you depends on your goals and what you're wanting to do, but a lot of them can be integrated really easily together.
Okay, we have a lot of alignment there, and I will say that at least the University of Iowa's best practices for establishing miscanthus include about a 100-foot prairie border around the outside because I think we all recognize that these are synergistic land management strategies.
Mm-hmm.
If anyone has other burning questions for Dallas, they better interrupt me because otherwise I'm going to say let's thank him one more time. So glad you could be here today, Dallas, and
Yep, thanks for having me.
good luck with harvesting.